To analyse cellular proteins, we use a technique called Polyacrylamide Gel Electrophoresis, also known as PAGE. So what happens here is proteins are loaded onto a gel and then an electric field is applied to separate the proteins. The movement and separation of proteins through the gel is dependent on two main factors, which is size and charge. So smaller proteins will move more quickly through that gel matrix, and also more negatively charged proteins will also move faster through that gel towards the anode. In the plant virus practical, we'll be interested in some small negatively charged proteins, so they should migrate quite well on the gel. There are two main approaches that are used in protein electrophoresis. The first is to do a denaturing gel. So you denature the proteins so they migrate on the gel just according to their mass and their charge density. So in this case you'd use a detergent like SDS, you add that to the proteins and that denatures them. So this is referred to as a denaturing gel or SDS PAGE. The alternative is to run the native proteins, i.e. you allow the proteins to maintain their secondary structure. So in this case the migration is a function of mass and charge and also the higher order structure, so that will affect the way that the proteins migrate on the gel. And this is known as native gel electrophoresis, and this is the approach that we're going to be using in the plant virus practical. So what we're going to do is to extract proteins by grinding up leaf material into a non-reducing, non-denaturing buffer, so that will allow the proteins to maintain their secondary structure and their native charge density. And then we'll go and analyse those on an acrylamide gel. This is the gel tank, which contains the gel and the buffer solution and the two electrodes at the either end of the tank connected to the power source. So once you've got your protein sample, you'll use a Hamilton syringe to introduce the sample into the wells in the top of the gel. So the gel is held between two glass plates and it runs vertically, and it's usually easier to see the wells by standing slightly over the top of the gel, so you're looking down between the plates. When you're using a Hamilton syringe to load the samples, take care not to pierce the gel, and also make sure that the sample doesn't spill out of the wells. You want to do it nice and slowly and calmly so you've got really nicely, neatly loaded gels. The wells are at the top of the gel, so you'll load the gels in there, then we'll apply a current to the gel and that will go for a designated length of time. After electrophoresis is complete, the separated protein bands can be visualised by staining the Kumasi blue dye, and that will allow you to see the various different bands of protein, and then we'll establish which proteins are in each band.